Recently I have become interested in Reuleaux polygons. You may recognize the Reuleaux triangle if you are familiar with Gothic architecture or mechanical engineering. Reuleaux polygons are curves of constant width, like a circle, meaning no matter how you rotate them, the distance across them stays the same. When rotated around their axis, they form surfaces of constant width. I have not been able to find any tools for creating Reuleaux polygons in Blender, so I decided to make one. My geometry node takes 6 inputs: side count, radius, side length, side divisions, and sweep divisions. The first step is creating a mesh circle, also known as a regular polygon, for the arcs to be built on. The circle is created with a number of vertices equal to the side count. If the side count is even, 1 is added since a Reuleaux polygon must have an odd number of sides. Then it checks to see if a polygon of the given side length and number of sides would have a greater radius than the input radius. If so, it uses that radius, and if not, it uses the given radius. I'll add a side length, since much of the use of the tool will probably be used to create Gothic arches, which will often have a given span in mind. For each edge of the polygon, it creates a curve line and resamples it to have the number of vertices given by the side division input, plus 1. Then each point in the line is set to be equally distant from the opposite vertex. This may seem obtuse, but I did it this way because the dedicated arc nodes in Blender have no option to construct an arc given 2 endpoints in the center. All of these arcs are joined together. If the sweep divisions are less than 3, this curve is turned into a mesh, the overlapping vertices are merged, and it is output. However, if the sweep divisions are 3 or greater, the shape is cut in half and used as the profile curve for a curve to mesh, using a circle curve resampled to have the same number of vertices as the sweep divisions. Because it is impossible to use a circle with a radius of 0, and I didn't want a gap at the top, I instead opted to use a 1 meter radius circle and move all the vertices inwards 1 meter. Reuleaux polygons are usually regular, but they don't have to be. At one point, I had planned to include the ability to create irregular ones as well. The only requirement is that each vertex is an equal distance from the 2 opposite vertices. However, for an irregular polygon to meet that requirement, it must have 7 or more sides. And since the vast majority of users will probably be using the Reuleaux triangle only, I decided to scrap this, as it would be a lot of work for a very niche feature. I hope you find this tool useful for architecture, engineering, and any other situation where you have a need to create this fascinating class of shapes.